यस आई थिंक हो गया होगा. हमजा, हिबा, खालिद, ये बच्चे भी चले गए क्या कहीं? हेलो.
Yes, sir. Really.
Doing, still doing. Yes, Hamza, Hiba, Khalid.
Yes, sir.
Done or still doing?
After doing.
Doing. कौन सा सवाल? Which one? Which one, Hamza? Don't tell me you are doing the first one only. Yes, Hamza. Which one? Yes, Hamza. Done. Hamza. Done. No. What happened? Am I not audible?
Yes, sir.
What? Yes, sir. Attendance नहीं ले रहे हैं हम.
Sir, no, actually I got disconnected.
अच्छा, now you are connected. So now you tell me. How much is done? 1 is done, 2, 3, 4, 5. How much is done?
3 is done.
Okay, 3 is done. 4, 5
Yes,
remaining.
sir. Yes, sir.
Okay, what about Hiba? How much is done, Hiba? So third one. Okay, fine. Done or not done, guys? What happened?
Done, sir.
Done. Okay. So in the first structure, you will be getting what? CH3, CH2, CH2. How many carbons? 3 carbons, right? So you will be getting 6 carbons here. Yes or no? You all of you got hexane in the first question.
Yes,
All of
sir.
you got hexane.
Yes,
Okay.
sir.
Now what is A? What is A?
CM.
Sorry. What is
Calcium
A?
oxide.
Yes. Calcium oxide, huh?
Yes.
Calcium oxide in the presence of NaOH also. Okay. So if you look at the reaction, where is that reaction? Yeah. So this is the reaction. No? So both of these in the presence of these two things, you will be getting. So just for the to be in safe side, you write NaOH also. But the presence of Na, it represents that sodium hydroxide was already added. But to be in safe side, you write here NaOH also. What is B? What is B? Huh, guys, what is B? No idea. Electrolysis, no? Electrolysis. And in this, you will be getting. Why are you guys not replying?
Sir, I have net lag sometime.
What about Hamza, Hiba, Khalid? You got this? Yes or no? Hamza, Hiba?
Third
Yes, I
one,
got it.
Yes, Hamza, tell me.
the third one I didn't get.
Acha, what about fourth one?
Not sure about that one. I mean, I was not sure.
Okay, so कैसे करना रहता है बताइए इसमें? What did I say? How to do it? देखिए, you make these two compounds and make the halogen face each other. Br, and you make this once again. But you have what? Faced the Br. You have faced what? The Br towards each other. You remove this with sodium, है ना? You have Na here, so NaBr will be removed. NaBr and NaBr will be removed. And what you will be getting? Okay. Similarly, for this also I said that you make this compound 2 times. Both of the times the Br should be facing, है ना? यहाँ पे Br था आपका. यहाँ पे Br था आपका, है ना? So you have to erase that Br and just form a bond. And just form a bond. So this is what? 2, 3, 4, and 5. This 2, 3, 4, 5. Tetramethyl. 1, 2, 3, 4, 5, 6, hexane.
Yes, sir, I got correct.
Okay. So write this. Tell me if you're done. Hi guys, done all of you? Yes or no?
Yes, sir.
Right next. Right next, the physical properties of alkene. Please, please revise daily. Okay, organic chemistry, please revise daily. If you don't revise daily, you will be forgetting things, and that will make a lot of problems later on. Number one, first thing is that the nature of intermolecular forces. So alkenes are non-polar. And hence only van der Waal forces of attraction are present. Van der Waal forces of attraction are present, है ना? And that too weak, right? Weak van der Waal forces of attraction. It is completely non-polar. Second is the boiling point. Second is the boiling point. So in boiling point, what happens? The boiling point of alkenes is obviously low because they don't have good intermolecular forces of attraction. It's low. Boiling point is low due to weak van der Waal. I'm writing van der Waal as VDW forces, low due to weak van der Waal forces. Next is boiling point increases with increase in carbon number. Increase in carbon, है ना? That means if I talk about methane, ethane, propane, butane, so if I go from lower carbon to higher carbon, the boiling point is going to increase, because if I have large size, then the electron distortion, then we have more electrons. If the electrons are more, then we have more electron distortion can happen, and more electron distortion can happen. Van der Waal forces will be high, and the boiling point will be high. The next is boiling point decreases with increase in branching. We have seen this point earlier also. Increase in branching. Next is melting point. Melting point. So in melting point, there is kind of irregularity. There's no such very good trend, but in general, you can see if I go from very low to high, in general, the trend is increasing. In general, the trend is increasing, but there is quite irregularity. Okay. So the irregularity is that alkenes with even number of carbon has higher melting point or high melting point compared to those to the immediate odd ones. But still, the melting point increases with increase in carbon atom. Okay, but if I look at odd even, then if I will go from odd to even, there will be not much increase in the melting point. But if I go from if I go from odd to even, there will be large difference. If I go from even to odd, there will be not much difference. This is due to even numbered Alkanes are tightly packed due to the terminal carbons on opposite side. They are on opposite side. That is why they are closely packed. If I look at this type of structure, then I can. So these are very tightly packed, very nicely, and where they are very tightly packed. Okay, because these are in two different ends. Next is solubility. Next is solubility. Fourth, I guess. Solubility. So there is one rule of thumb, that is like dissolves. Like, है ना? And since alkanes are non-polar, hence they don't dissolve in polar solvents. What are polar solvent? Polar solvent which has some dipole moment, है ना? So polar solvents such as H2O, alcohols, है ना? Water and alcohol, these are the most polar solvents. So what does alkane do? They dissolve in, they are soluble in non-polar solvents, dissolve non-polar organic solvents or weakly polar solvents such as benzene, ether, etc. Okay, so for these type of things.
Sir, what
Okay,
is
so this
the
is all
first
about the
point again?
like dissolves like. Acha, like dissolve likes means polar substance will be dissolved in polar substances and non-polar will be dissolving in non-polar substances. That's it.
Okay, sir.
Okay, so अच्छा ये बताइए आप, we have sugar and we have salt, which gets dissolved easily in water.
Sugar.
Which dissolves easily in water, salt or sugar?
Sugar.
Salt.
Sugar कौन बोल रहा है? Hamza, did you say sugar?
Yes, sir.
Why do you think sugar gets dissolved easily?
I think so.
क्या भाई? नो, कितना दिन हो गया आपको पानी में कुछ घोले हुए? Sugar takes more time, है ना? Sugar takes more time only because it is organic. So it also has hydrogen bonding. Sugar has some OH bonds, but salt it is like Na and Cl, right? So it is like completely ionized. Okay, it is completely ionized. So whenever we are talking about solubility, if we have polar substances, so it will dissolve in polar solvent. If we have non-polar, it will dissolve in non-polar. It will be dissolved in non-polar solvents. Okay, so that is the meaning of like dissolves like. Next is the chemical property of alkenes. chemical properties of alkenes. First thing is that the reactivity of alkene is very low, because alkenes are very less reactive. The first reason is that there are only two types of bond. There is C bond and there is CH bonds. So for example, if you are going to react anything, so you must have seen this example many times. जब हम लोग organic chemistry पढ़ रहे थे, CH3 Br plus NaOH. So it is going to give me CH3OH. So whenever you are reacting something, and if you want to learn about the reactions of alkenes, reactions of alkene, reactions of alkyne, reactions of alkyl halide, alcohol, ether, phenol, aldehyde, ketones, benzenes. So in that you have to see which of the bond is getting broken, which of the bonds can break, right? Because if you are reacting something, that is going to get destroyed. The bonds in those reactant, the bonds are going to break. Yes or no? Correct? ऐसे देख सकते हैं ना हम लोग?
Yes, sir.
Right. Okay. So in alkenes, we have only two types of bond. We have either the CC bond or the CH bond, and both of the bonds are non-polar. Both of the bonds are non-polar. They are non-polar, and what? And they are, and bond strength is high. Bond energy is high. They are strong bonds. Overlapping is also good. That is why the reactivity of alkenes is low. The reactivity of alkene is low. Now, but still, with some extra conditions, we can do some reactions. So first reaction that we'll be looking at is the substitution reaction. Substitution reactions. Okay. Now in substitution reaction, what happened, guys? You remember we have done now?
Yes, sir.
I gave you.
Yes.
क्या होता है substitution में बताइए? क्या होता है substitution में?
We will substitute another substance.
So for example, substitution reaction. Okay. So one of the atom or group of atoms get replaced. Yes or no? In substitution,
Yes, sir.
by some other atom or group of atoms, right? Okay. So when we are looking at substitution reactions, in that what will happen? You will have this hydrogen of alkene will be replaced by something else. Okay. What will be getting replaced? Hydrogen will be replaced by something else. So in that we have the first reaction, that is halogenation. Okay, so halogenation, it happens. And that is the reaction of alkane with halogen in the presence of, it happens in presence of helper. You remember helper? Helper पता है आपको? याद है? नहीं याद है? Do you guys remember helper? Yes or no? नहीं. What do you
Remember
नहीं
it, but I forgot the full form of that.
like full form of that? Okay. So this is heat, electricity. This is light. This is peroxide. Okay, it happens in the presence of these things. Mostly you will be getting instead of light, h nu. H nu is also a form of light only. H nu means wave. Wave means light, electricity. Heat you can show as delta. So most of the times you will be getting these two things, either heat or light, and sometimes peroxide. I have not seen electricity given in any questions till now, but electricity is also one of the ways to generate free radicals. So in the presence of these, that means it occurs via free radical formation. So here what do we have? Free radical formation. Okay, it happens via free radical formation. That means this is our intermediate. Free radical is our intermediate. So whenever we are talking about intermediate that is free radical, then we can also talk about the rate of reactions. You will also get rate of reactions. So if I have an alkene like this RH, okay, I have an alkene like this RH, and I react this with any halogen that is X2 in the presence of any of these things or heat, I will be getting this hydrogen will be replaced by, देखिए ऐसे होगा कि यहाँ पे है आपके पास X and X, है ना, simple substitution reaction. So what are you forming? You're forming haloalkane or alkyl halide as you want to see it, haloalkane, and you will be getting hydrogen halide, hydrogen chloride, fluoride, bromide, or anything else. Now, whenever we have free radical, and the first thing is that if I want to talk about the rate of reaction, if I want to talk about the rate of reaction of halogens, which of them will be reacting fastest, and I'm comparing the rate of reaction and I am changing what I'm comparing the rate of reaction according to the halogens. So if I take F2 or Cl2 or Br2 or I2, है ना? So these are the molecules. These are the molecules, the halogen molecules. Now you tell me which of the following has strongest bond? Because what is happening? The XX bond is breaking, right? XX bond is breaking. So if the bond can be broken easily, then it will be a good reaction. Other thing, what can happen? Then we have to look at the Rx bond strength. We have to look at the Rx bond strength. So we will have to compare those two things. We will have to compare those two things. So if I talk about the bond strength of, fluorine, chlorine, bromine, and iodine, so I know that fluorine has the lowest bond strength because fluorine and fluorine is there. Even though they are very small and the overlapping is good, they have lone pairs. If you remember, we can easily break this bond because of lone pair repulsion. And also the Rx bond, that means carbon and fluorine bond, it will be very strong. Why? Because this is also of second period, this is also of second period. The overlapping of orbitals will be very good. This is the order that we have got, that fluorine is going to be reacting the fastest, followed by chlorine, followed by bromine, and at last we will have iodine. Okay, so this is the rate of reaction if I am comparing the halogens. Now let us look at what happens if I take an example. So I am taking an example of CH3, and there is a hydrogen atom. I'm reacting this with chlorine in the presence of sunlight. So what I will get? I will get H3C and a chlorine atom here. I'm ignoring the HCl as of now. Don't talk about HCl. We're just talking about the organic molecule. Furthermore, if I add more Cl2, then what is going to happen? This hydrogen atom, one of those hydrogen atoms, they also will be replaced. They will also be replaced, CH2, and you will get Cl2. If I add more Cl2, then one of these hydrogen atoms will also get replaced and you will get CHCl3. If I add one more times Cl2, then I will be getting CCl4. Yes or no? Tell me. You understand this point? You understand this series of reaction?
Yes, sir.
Okay. So I can say, if I have CH3 or rather CH4 plus Cl2 or rather any X2, and this X2 is in excess, and I do the reaction in the presence of sunlight, then at the end, what am I going to get? I'm going to get CX4. Correct, guys? Yes or no?
Yes, sir.
So it means that during this reaction, different halogenated product, different halogenated products are formed. Different halogenated products are formed, which are difficult to separate, Okay. Furthermore, if I'm going to form a particular haloalkane, and this method is giving me a mixture of product, that means I can say it is not a good method of, it is not a good method for preparation of haloalkenes, as it gives mixture of products. Okay, now we will look at mechanism. So please look very carefully. After mechanism, we'll be doing questions. Mechanism is very important. Mechanism. The reaction we have CH4 plus Cl2 in the presence of H nu. It is going to give me, I'm just making one halogenated product, that is CH3 Cl plus HCl. What is mechanism? Mechanism is what scientists they propose. They propose how a particular reaction would have happened. So how do they propose a mechanism? How ऐसा कोई experiment नहीं होता जिससे आपको mechanism पता चल जाए. So mechanism is always proposed. कि ये हुआ होगा, फिर ये हुआ होगा, फिर ये हुआ होगा, then like this. It is a series of events, है ना? Series of chemical reaction that would have led to this product CH3Cl. Now, in reactant we have three things. Two are chemical species and one is condition. Sunlight is the condition that we are giving, and we have the species, chemical species reactant. This is substrate. This is our reagent. So usually reagent is something that is going to start the reaction. So in the first step, what happens? We have Cl, chlorine bond. In the presence of H nu, I hope you guys know that it is going to break the bond and there will be a homolytic fission and they are going to form Cl free radical, and there is one more Cl free radical. Yes or no? Correct?
Yes, sir.
Okay, so we have formed free radical. Next is, the next step, we have carbon, which has 4 bonds. These are just representations, not actual structure, because actual structure is tetrahedral. Huh? Here we have CH4. And what happens? One of the Cl free radical, it attacks on the hydrogen atom with one of its particle, hydrogen. So here we have hydrogen. Hydrogen comes like this, chlorine comes like this, and they form a bond. And then we have CH3 free radical. Correct? And hydrogen and chlorine, and they have formed HCl. Now we have used one of the chlorine free radical, another chlorine free radical. It will come and it will interact with the CH3 free radical, and it is going to make a bond like this. Okay, bond like this. Then at last, what is going to happen? At last, you will take all the free radicals that we have prepared. So we had Cl free radical. Cl free radical can also combine with Cl free radical, and it can make what? And it can make what? It can make Cl2, Cl free radical, और rather CS3 free radical. तीसरा स्टेप यहीं से हो जाएगा आपका. CS3 free radical can also combine with CS3 free radical, and they are going to form CS3. Okay, CS3. So this is the first step. It is known as chain initiation step, because there is a chain of reaction that is going to happen. Chain initiation. Second step is chain propagation, because what is happening here? One of the free radical, it is combining and making a neutral atom, and it is propagating the free radical to some different compound. So Cl free radical is making CS3 free radical. That means it is propagating. This is chain propagation. And then these are the steps for chain termination, because the free radicals, they are combining and they are forming a neutral atom, a neutral atom. So first of all, what happens? From neutral to free radical to free radical, and after that free radical to neutral once again. So you have starting में neutral to free radical. So this is the common theme of chain initiation step. Then free radical 1 plus a neutral atom, and it will give you a second neutral atom plus a new free radical. Okay, plus a new free radical. As you can see here, CH4 was neutral, Cl was free radical. Now we don't have any Cl free radical, but we have CS3 free radical. And at last, what will happen? FR1 can combine with FR1 to give something neutral. FR1 can combine with FR2 to give something neutral. Free radical 3, sorry, free radical 2 and free radical 2 can combine to give a neutral. So this is chain termination, chain propagation, chain initiation. Okay, 3 steps. Important point is that we are forming a free radical. This is the most important point. Okay, this is the most important point, that we are forming a free radical. So let us take an example. Let us take an example of this compound. If I react this with Cl2, the presence of H nu, then we can see there are 2 types of hydrogen. One is terminal hydrogen and one is second degree hydrogen. So there are only 2 types of hydrogen. So both of these hydrogen can be reacted. Right? Any of these hydrogen can react with the chlorine free radical, and it can form compound, and that is why you will be getting 2 compounds. One will be CH3CH2, CH2 chlorine, and the other compound that you will be getting is CH3, CH, CH3, and chlorine here. So as you can see, I'm reacting one thing, but I'm getting a mixture of product. I'm getting a mixture of product. Got it, guys? Yes or no? Tell me. Got this?
Yes, sir.
Okay. Right, next. A note. Number 1 is fluorine is reaction with fluorine. Is so fast that it is explosive. So usually we don't do any reaction with fluorine, and it is so fast and it is explosive, which leads to breaking or rupture of CC bonds. So generally CC bond should not break in halogenation reaction, but fluorine is so reactive that it is kind of explosive and so much heat is produced that CC bond can also break. Second is iodination is reversible. Iodination of what? Iodination of alkene is reversible. That means CH4 plus I2. What happens? It will form CH3I, but the CH3I bond is so weak that it reacts with HI that we have just had here, and it again forms CH4I2, and it again forms CH4I2. So what can we do? देखिए आप लोगों ने equilibrium पढ़ लिया ना? So see, how do people tackle this type of problem? What will happen? Please tell me what will happen if I remove one of the products, the reaction will go forward or backward? If I start removing one of the product, what will happen? Reaction will move forward or backward? Arey, what happened, guys? You guys are so silent. Okay. Let me say it like this. I want to shift the equilibrium towards forward reaction. Okay. I want to shift the equilibrium towards forward reaction. So what can I do? I can do two things, right? I can either add more and more. I can either add more and more reactant molecules, yes or no? Correct?
Yes,
Oh,
sir.
what happened? Guys, Hamza, Hiba, Khalid, आप लोगों ने इक्विलिब्रियम पढ़ा है ना?
Yes,
ऐसे
sir.
एकदम शांत बैठे हैं बिल्कुल. And what will happen if I remove some of the product's concentration will decrease? So what will happen? The equilibrium
It
will
will go
shift
backward.
forward ना. If I
Yes,
हाँ
sir.
हमजा
Yes, sir.
फॉरवर्ड ना, ये
Support.
कम करेंगे तो फॉरवर्ड जाएगा फिर, क्योंकि उसको ह्यूमन क्या कर रहा है? कम कर रहा है. इक्विलिब्रियम क्या चाहेगा? ज्यादा करे. ज्यादा करने के लिए फॉरवर्ड जाना पड़ेगा. ओके, दैट मींस आई कैन डू समथिंग. आई डोंट वांट दिस HI प्रोडक्ट, राइट? आई डोंट वांट, हमको चाहिए ही नहीं HI प्रोडक्ट. आई नीड दिस हैलो अल्कीन. आई नीड दिस halogen. So what I can do? I can add one more reactant. I can add one more reactant which can react with HI. So it will reduce the concentration of HI and the reaction will move forward. So what they suggested? They suggested that we can add some strong oxidizing agent. Strong oxidizing agent such as HNO3 or HiO3 is added, which converts HI to I2. तो देखिए दो काम कर रहा है. It is decreasing the amount of product, and I2 जब बन जाएगा तो क्या? Reactant का product, reactant का concentration, it will increase. So ultimately it is going to go so much forward, right? It is going to go forward. So what happens? You have CH4 plus I2, and we will add HNO3. There will be some heat required. And then you are going to get CH3I plus H2O plus NO2 plus I2. ऐसे काट मत दीजिएगा Y2 I2, ठीक है? Both the I2s are important. Both the I2s are important. The reaction, if I talk about HNO3 and I2, it happens something like this. H2O is formed plus NO2 is formed. Sorry. HNO3 plus HI, इसका ये रिएक्शन होता है H2O plus NO2 and they will form I2. Okay, so this is the reaction that happens. So essentially I can say first what happens, these forms CH3I plus HI, है ना, plus HNO3, because HNO3 अब तक react नहीं किया है. Now these two reacts to form these three elements and the CH3I is CH3I. Okay, CH3I is CH3I. So write this down. Sorry, don't write this down. Just let me know if you're done. बताइए समझ में आ गया आप लोगों को? Yes or no, guys?
Yes, sir.
Okay. Next is, when I was talking about this compound here, right? These two. So we are getting two products. We are getting two products. So one of them will be major. So one of them will be major. The other will be minor. So let us look at that. So I have CH3, CH2, CH3, and I know that I am going to get two products, but they both of them they will be going through a free radical intermediate. So I can make a free radical intermediate. This is first carbon atom. This is the A carbon atom. This is the B carbon atom. So if I'm making a free radical like this, CH2 free radical, CH2, CH3. If I'm making free radical on B, then I will have CH2, CH free radical, CH3. So now you tell me, free radical it is what? Electron rich or electron deficient? Electron rich or electron poor?
Electron poor.
Okay. So now which is more stable, A or B? What do you think? A is more stable or B is more stable? Tell me. सब भूल गए ना? ऑर्गेनिक केमिस्ट्री सब भूल गए आप लोग? तीन इफेक्ट देखते हैं ना, इंडक्टिव इफेक्ट, मेसोमेरिक, हाइपर कॉन्जुगेशन, इंडक्टिव. देखिए ऐसे काम नहीं चलने वाला है ना. द chapter organic chemistry, some basic concepts and techniques that will be useful in 12th standard also. So you have to keep revising it. Okay, you have to keep revising it. Is anyone flipping at least the notes? Yes or no? कि बस ऐसे ही अपना तो देख के बताइए फिर नोट्स में. पढ़ाया हुआ है आप लोग को, आप लोग उसमें भी तो बताया हुआ. देखिए, कंपेयर द स्टेबिलिटी. क्या चाहिए आप लोग को और? ऐसे नहीं चलेगा ना. देखिए कार्बन फ्री रेडिकल, tell me which is more stable. Is there any resonance? Is there any resonance? ये भी नहीं पता. What happened, Hamza? Yes, Hamza, are you there?
Yes, sir.
You're looking at notes, yes or no?
Yes, sir. Checking that.
So पहुंचेगा नहीं फ्री रेडिकल में कोई एग्जांपल में जीओसी में कहीं पे भी.
Yes, sir.
So tell me, you have na carbon free radical. There will be a topic cation, carbon free radical, and then carbon ion. You have that in your notebook.
Yes,
नहीं मिल
sir.
रहा है इनको. अच्छा मिल गया.
No, I'm just checking out the.
अच्छा. What about you, Hiba?
So I'm checking there.
Okay.
The A will be more stable.
Okay. So what are the three factors? Like, how are you saying which factor? There are some factors now that affect the stability of carbocation, carbon ion, or free radical. So what are those factors? Tell me that.
So I've seen the degree, like 1 degree is more stable, and then 2 degrees and 3 degree.
1 degree is more stable. For
More
carbon
stable,
free
yes.
radical. Carbon free radical.
Yes, sir.
Acha. So we have done that in note. You have that in your notes.
No, so that was in my school notebook. So I checked from that.
भाई स्कूल नोटबुक नहीं उसको तो रख दीजिए आप. नहीं वही हम सोच रहे हैं. दैट्स नॉट राइट हमजा. वो फ्री रेडिकल के लिए नहीं होगा, कुछ और के लिए होगा. देखिए कार्बोनाइन के लिए तो नहीं है कहीं.
Yes, sir, carbon ion.
अरे भाई वही तो कार्बन फ्री रेडिकल कार्बोनाइन को आप मिक्स कैसे कर सकते हैं हमजा. हम इसीलिए तो पूछे कार्बन फ्री रेडिकल के लिए है क्या. नहीं ऐसे नहीं. क्या हुआ. व्हाट अबाउट अदर्स. खालिद.
Sir, I think A is more stable because it.
हम वो नहीं अभी तो A और B में तो ट्रू फॉल्स जैसा हो जाएगा ना. I am more interested in the factors. Tell me, what are the factors that affect the stability of any intermediate? वो बताइए आप. Can all of you see I have sent you a PDF?
Yes.
Guys, open that. ठीक है. So see, yes, Salman, did you get that PDF?
Yes, sir, I'm forwarding.
हाँ, you forwarded to Khalid, है ना? So first thing is that there are few things that you have to understand before determining the stability. First is that you have to identify what is the intermediate, whether it is carbocation, free radical, or carbon. Then you have to divide them. You have to divide them between electron deficient and electron rich or negatively charged. Huh? So those two are the carbocation and free radical. They are, what are they? Electron deficient. Carbon ions are electron rich, negatively charged. Okay, electron rich, and they are negatively charged. And what is stability? Stability is inversely proportional to the charge. So the charge should decrease and the electron deficiency should decrease. Right? So if something is electron deficient, we have to make it, we have to decrease that deficiency. That means you have to give electrons. That means we have to give electrons. Now you have to remember these rules. Okay. So we have only one rule of thumb, that is stability is inversely proportional to charge and electron density. And after that, you can lead to conclusions such as electron releasing or donating group stabilize carbocations at free radicals because we are decreasing the charge. Because if we are giving charges, if you are giving electrons to positive charge, then it is decreasing the charge. If you are giving electron to something which is electron poor, that means you are decreasing the deficiency. Okay. So these are the 4 points that you have to learn, just 4. And not even that, what I suggest is that you learn this rule of thumb. Stability is inversely proportional to charge. Then you try to think about logically what is happening. Okay, after that, the main point is you have to know what are the plus I, plus M, minus M group, what is the conditions for hyperconjugation. Okay, so those things comes later on. But first thing is that whether the electron donating group will stabilize it or it will destabilize it. So now you tell me, our intermediate is electron deficient or electron rich? Tell me. Electron deficient or electron rich, guys? ये भी नहीं आप लोग बोल रहे हैं, हद है.
Electron deficient.
Okay. Next, you tell me. You keep your notes. You keep your notes with you. Okay. Is there any resonance? Because we have 3 things now that stabilize. You have three things: electron donation or withdrawing group. It can be through resonance or mesomeric effect, or hyperconjugation or inductive effect. So, and we know that resonance is what most effective, then hyperconjugation, and then inductive effect. So first I will look whether there is any resonance. बताइए, is there any resonance? Is there any resonance? जाइए ना, conditions for
No.
resonance लिखवाया ना. हाँ, go to conditions for resonance. Please turn your mic on, guys. पूरा चैप्टर पढ़ा के हैं, आपके पास नोट्स है, then also you are not answering. Tell me, is there any condition for resonance? Is resonance here, yes or no?
No, sir.
No. Because at least one pi bond should be there, or there should be lone pair, or there should be lone pair or positive charges. Khair. What is the condition for hyperconjugation? Look and tell, what is the condition for hyperconjugation? What is the condition for hyperconjugation?
Compound should have like at least one sp carbon atom.
पढ़ के बताइए आप, याद तो नहीं है आप लोगों को.
sp2 hybridized carbon atom.
Sigma bond.
पढ़ के बताइए, वही हम बोल रहे हैं, आप लोग को कुछ कुछ बोल रहे हैं आप लोग. जो लिखाया है हमने उसी को पढ़िए बस. Look at your notebook and read what is written. There will be a section, na, condition for hyperconjugation.
Hydrogen atom?
अरे read ना, are you reading, सलमान?
Yes, sir.
So हम ऐसे लिखाएंगे कहीं पे हाइड्रोजन एटम बस. And I ask very
And
simple things. Na.
one with respect to sp2 hybrid carbon should have at least one hydrogen atom.
Huh. This is a statement, na, Salman. And what did you say? Hydrogen atom. Like, it is not even a sentence. How it will make sense? How it will be a condition? Hydrogen atom. I ask you simple things, guys. है ना? So, like, please try to do at least that much. Okay. So now you tell me, is there any sp2 hybridized carbon atom? हमजा आपके नोट्स में है कि नहीं है? आपको नोट्स भी नहीं मिल रहा है हमजा. हिबा?
Yes, sir. है.
What about you, Hiba? Yes, Hiba? नहीं, हिबा के नोट्स में. Okay. So now you tell me, is there any sp2 hybridized carbon atom in A and B? क्या आप लोगों को कुछ नहीं याद है क्या? क्या हो गया? आप लोगों को हाइब्रिडाइजेशन भी नहीं याद है? 3 कार्बन है. In A carbon, you look at the first carbon atom. और हाइब्रिडाइजेशन कैसे निकालते हैं? स्टेरिक नंबर याद है कि नहीं याद है? स्टेरिक नंबर भी भूल गया. केमिकल बॉन्डिंग. Yes or no?
Yes, sir. Yeah.
बताइए. So for if sp2, then what should be the steric number? अच्छा, खैर वो छोड़िए आप. Tell me for the A carbon, the A compound, sorry. For the A compound, we have 3 carbon. I'm going from left to right. The first carbon atom, what is the steric number of the first carbon atom? What is the steric number of the first carbon atom? Can you please speak loudly?
2.
2. That means what? It is making 2 bonds. Right? यही मतलब हुआ
Yes,
ना?
sir.
ओके, 2 बॉन्ड बना रहा है, सही है. व्हाट अबाउट द नेक्स्ट वन, नेक्स्ट कार्बन? What about the next carbon on the same compound A? What is the steric number? C.
The 3.
3. Okay, बहुत सही. Either you guys are not studying, okay, or you are not attentive, है ना? But the end product is that you are wrong. I don't know what is the case, okay, but the end product is that you are wrong, and you are utterly wrong. I mean, I can't even imagine to say how wrong you guys are. I'm asking what is the, how many bonds are there, and Hamza, you are saying 2 bonds. 2 bonds तो हाइड्रोजन के साथ ही हो जाएंगे, कार्बन के साथ बॉन्ड भी होगा ना एक. So either you guys are not studying or you are not paying attention, है ना? So there's only 2 things. अब तो बताइए sp2 है कि नहीं है, क्या है एकदम कुछ, like have you guys gone blank?
Sir, in the B1, right?
A B किसी में बता दीजिए भाई.
B has sp2.
B has sp2. Which carbon is sp2? Wait a second, this is CH3 only, okay, not CH2. Guys, I'm very disappointed. Like I have written each and every point. Delocalization of conjugated CH bond, CH sigma electrons with pi bond, positive charge और free radical. यानी ये तो है ना कि अगर आपके पास कहीं पे पाई बॉन्ड हो, कहीं पे आपके पास पॉजिटिव चार्ज हो, कहीं पे आपके पास फ्री रेडिकल हो, देयर यू विल बी हैविंग हाइपर कॉन्जुगेशन. रियली लाइक can't say anything. I'm just disappointed, nothing else. So this CH2 is what? sp2 hybridized because it has 3 bonds. This is also sp2 hybridized because it has 3 bonds. Alpha hydrogen बता पाइएगा आप लोग? Can you guys tell me alpha hydrogens? How many alpha hydrogen are there in A and B? नहीं आता है. Alpha means adjacent. Adjacent carbon has 2 hydrogen. That is why this will be 2 hydrogens. Here, this carbon has 2 alpha hydrogen. This is also alpha hydrogen. This is also alpha hydrogen because both of these are adjacent to carbon. And if I talk about the number of alpha hydrogen, that will be equal to 6. And hence I can say A is less stable than B, right? B is going to be more stable. And hence this B is going to produce the major product that will be CH3, CH. And if I add Cl2, I will get the chlorine here and CH3. Since it is more stable, the substrate will be forming more and more of this intermediate. And if this intermediate is in large concentration, it is going to form the product that is 2 degree. That is 2 degree. That is why you can write many questions. Write the major product. the presence of Cl2 and H nu is going to give you CH3, CH, chlorine, and CH3. This will be major product. If I have something like this, then in this, all of the carbon atoms are same. All of the carbon atoms are 2 degree. Whether you form free radical here, 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 or anywhere else, it is going to be same. And that is why you will have only one major product, that is Cl2 H nu Cl. But if I have a methyl group attached here like this, then in the presence of Cl2 and H nu, I can either have this type of free radical that is 2 degree, or I can have a 3 degree free radical here. So 3 degree free radical is going to be more stable because it will have more number of alpha hydrogens, and hence I will be getting a product in which this is the methyl group that was already present, and I will add a Cl here only. I will add the Cl here only. You can also be asked a question: which of the following will give only one monochloro product? Only one monochloro product on halogenation. On halogenation. So if you look at these structures, so A structure has CH3, CH2, CH2, CH3. B has CH3, CH2, CH3. C structure is CH3, CH. There's a CH3 here, there's a CH3 here. The C structure is, D structure is CH3, carbon, CH3, CH3, and CH3. So if I look at the A structure, then I can see that there are 2 different types of carbon atom. There is a terminal carbon atom which has hydrogen. So please remember, only the CH bond is breaking. So you will be seeing the CH bonds which are different. So the CH3 and the CH3, these are different. The CH3 and the CH2 is different. This CH2 and this CH2 are same, and the CH3 and this CH3 are also same. Right? So we can form how many products? We can form only 2 products with this compound. You will be forming either.
So the D1 will be the answer, right?
No. Only one product ना. एक तो आपको यहाँ पे ऐसे एक product मिल सकता है. And you can also get a product in which you will have Cl here, the second carbon. 2 products. If I talk about the B1, then you can get 2 products. एक तो आपका Cl कहाँ हो जाए, बीच में आ जाए. Plus you can also get a minor product which is Cl on the terminal carbon. If I talk about the C structure, then in this case, all of these CH3s are same, but still I will get 2 products, right? So one can be in the terminal carbon. There can be a Cl here. And these are the CH3 plus what I can have. You can have a major product in which the Cl will be here. But if I look at this particular D structure, here these CH3 are same. And even though this carbon is different, but this carbon does not have any hydrogen. That is why it is not, this carbon does not have any hydrogen, right? If it does not have any hydrogen, that means chlorine cannot attack here. Chlorine will only attack if it has hydrogen to form HCl, to form HCl. That is why this is the structure, which is going to give you a single product. That is, in any one of these CH3s, I will be combining Cl, and the product that you will be getting is CH2, carbon, CH3, CH3, and CH3. Okay, so these are the type of questions that you can get. These are the type of questions that you can get. Next is the rate of reaction. The rate of reaction. So once we have looked at the reagent, if the reagent is different, fluorine, chlorine, bromine, iodine. Now let us talk about the substrate. So in substrate, what do we have? In substrate, we have alkane. So alkane can be of three types. If it has to have an hydrogen atom, it can be either of 3 degree. So 3 degree will be most fastest, followed by 2 degree, followed by 1 degree. 1 degree. Alkane. Why? Because the reaction occurs through free radical mechanism and 3 degree free radical is most stable. Okay. Next reaction is combustion. In combustion, what happens? In combustion, we react alkenes with oxygen. So there will be So there will be carbon. Let us say alkane CH4. There are two types of combustion that can happen. There is a complete combustion, or there can be incomplete combustion or controlled combustion. There will be two different types of products that will be formed. Two different types of products. Both of the cases, it will be reacting with oxygen only. But this is complete combustion. So if it is happening, if you are having complete combustion, then you will be forming CO2 plus H2O. But if you react this with O2, and you can also write controlled here, or what else you can write? You can write here incomplete. So see, whenever you burn paper, so paper, it has some mass, right? Paper, it has some mass, but the ashes that you, the ashes mass, it is obviously what? Very less than, it is very less than the actual mass of paper that you originally had. What does it mean? That means some of the paper that you burned, in burning process, you had carbon in paper, carbon formed carbon dioxide. But at the end, there are some ashes, and those ashes are carbon. And those carbon ashes are only because of incomplete combustion. And in incomplete combustion, what happens? You will get carbon that is solid plus H2O. The H2O will be liberated out, right? It will be liberated out. This carbon is known as carbon black. This carbon is known as carbon black. Okay. And even though if you have a complete oxidation or complete combustion, their carbon monoxide is formed in very little proportions. Okay. Next is, if you have, this is incomplete combustion. Next, we can have controlled oxidation. Right. Next. Controlled oxidation. Now, in controlled oxidation, we use different reagent to form different types of products. So, for example, let us start with a simple molecule, that is CS3. Okay, CS3. So in all of them, I am going to react it with oxygen with some catalyst. Okay, so the first reaction that I'm going to do is with O2, and in the presence of copper at 500 Kelvin temperature, and 100 atm of pressure. 100 atm of pressure. Then this leads to formation of CS3. Wait a second. Actually, we can't generalize these things because different types of substrates are used. Here I can form only methanol. So I will have to take the first reaction. You can write it like this. 2 moles of CH4 when reacted with oxygen in the presence of copper at 500 Kelvin and 100 atm pressure is going to form 2 moles of methanol, CH3OH. It is going to form methanol. Okay. Next is, if you have CH4 plus O2, now in the presence of molybdenum oxide, MO2O3, you are going to form methanol. That means HCHO. Third is, if you have, let us say, CH3 plus O2 in the presence of CH3 COO twice, and manganese is here. Okay, manganese metals, it is coordinated with CH3 COO. The presence of heat, you are going to form CH3 COOH. That is ethanoic acid. And for example, if you have a secondary carbon, okay, or you have a tertiary carbon like this, all of these are CH3. And if you are reacting this with KMnO4, that is an oxidizing agent, KMnO4, then you are going to form an alcohol, and that will be a 3-degree alcohol, OH. That will be a 3-degree alcohol. So these are different types of reactions in terms of controlled oxidation. So in copper, you are getting alcohol. Molybdenum, you are getting aldehyde. If you're using manganese and it is acetate ion, then you're getting ethanoic acid. If you're using KMnO4, then you are going to get a OH group. Then you're going to get a OH group, that is alcohol. Next is a reaction with steam. Okay, reaction with steam. That is H2O, but in gaseous state. High temperature में H2O से अगर react में तो क्या होगा? So you have CH4 plus H2O gas, and it is going to give you carbon monoxide plus 3 moles of H2. We want to balance this. I think it is balanced. 4 2 6. Yes, it is balanced. It is done in the presence of alumina, Al2O3, at high temperature, 1273 Kelvin. Okay, so these are some reactions, and there are a few more reactions such as isomerization and aromatization that I will do tomorrow.